three different types of membranes which we mostly use into the Western blot. The first one is nitrocellulose, second one is polyvinylidene difluoride, that is PVDF, and the third one is the nylon membrane. The main reason to transfer this protein onto the membrane is to have the better handling capability, because gels are fragile and it can be broken easily. However, these membranes can easily carry the proteins without worrying about the wear and tear. It provides a better target protein accessibility. It makes a very low background signals, and these are highly reproducible. So the reproducibility is also very good in the membrane system. So all these three different membranes have some limitations or some advantages, which we will see. But more or less, the common things is that they provide these four benefits as comparison to the gel system, which we from where we are transferring these proteins onto the membrane. Let us go into the first membrane, that is the nitrocellulose membrane. I already showed that in 1979, when Harry Tobin and his colleague has done the first time electrophoretic transfer of proteins, they used this nitrocellulose sheet. So it is quite old membrane. It has been used for a long time. So basically what nitrocellulose is, it's a polymer of cellulose nitrate. So basically this nitric oxide is used to convert the cellulose and form the cellulose nitrate, which is also called as nitrocellulose, and it is a polymer of C6H9NO245 to the power, N. It means that this many number of time it is there in the membrane. So what are the advantages of this nitrocellulose membrane is that the protein immobilizes on the nitrocellular membrane through the hydrophobic interaction. It provides a high protein binding affinity. It is compatible with a variety of detection systems. The ability to immobilize proteins and glycoproteins. So it is having the ability to immobilize the proteins and the glycoproteins. And the protein binding capacity is somewhere around 80 to 100 microgram per centimeter square. So even though it is one of the longest used membrane in the protein system, it suffers from two major drawbacks. One is that it is having relatively low mechanical, thermal, and chemical strength. It means that it may be prone to wear and tear while processing. However, not so easy as the gel, and it is having relatively hydrophilic in nature. So again, we are using a lot of, if we are using washing or something with the water, it may get wear and tear. To overcome this problem, there was another membrane which is now mostly used in the protein labs, that is called as PVDF. Here the protein bind via the dipole and the hydrophobic interactions. It provides relatively high binding capacity. It causes low dye staining background. It is relatively hydrophobic in nature. It provides high thermal and chemical resistance than nitrocellulose, and the protein binding capacity is more than nitrocellulose, that is 170 to 200 microgram of proteins can be bound per centimeter square in PVDF as opposed to 100 microgram in nitrocellulose. The third membrane which is commonly used, that is the nylon. So there are several varieties of nylon which are used, like nylon 6 and nylon 6,6, which varies in its polymer composition. It also binds the protein by ionic, electrostatic, and hydrophobic interaction. The best advantage of nylon over PVDF and nitrocellulose is the protein binding capacity. You can see that it has the capacity of 480 microgram per centimeter square. So definitely it is way higher than PVDF and nitrocellulose. However, you can see that there is a drawback of high dye staining background, and it is also hydrophilic in nature. However, it is having excellent mechanical, thermal, and the chemical resistance. So all the three membranes do suffer from some disadvantages, but also offers some advantages. So for example, nitrocellulose, which can be stripped and reprobed, it is hydrophobic and electrostatic. It has the binding capacity of 80 to 100 microgram per centimeter square. The advantage is the tendency to exhibit lower background, but it is fragile, brittle, and that's why the use is limited, not limited, but comparatively lesser these days. However, with PVDF, it can be striped and reprobed. These are hydrophobic, having the binding capacity of 170 to 200 microgram per centimeter square. It is more durable than nitrocellulose, but it has to be pre-weighted with methanol or ethanol prior to use. However, in the nylon membrane, it also can be striped and reprobed. It is ionic, hydrophobic, and the electrostatic interaction which binds the protein with the nylon offers almost 480 microgram per centimeter square. It is having very high durability, and however, the disadvantage is that it is having high non-specific binding to strong anions, because nylon membrane is cation in nature, so it has the higher non-specific binding to strong anions.